Hello, KCS students. My name is David Gunza, your instructor. Today we'll be covering or discussing access control list, ACL. What is an ACL or access control list? An access control list is a set of rules used on network devices like routers, switches, firewalls to control traffic, right? So when we say traffic, we mean network. So you can literally set up an access control list in one router to block or deny access from remote access to income into your network, or actually you can also block your internal network not from going outside, or you can permit them from not going outside, right? From going outside to go outside. So standard ACL. So we have two types of access control lists. We have the standard and the extended. So with the standard, basically it just filters the traffic based on only on the source IP address of source network address, source host IP. So you basically block or permit a remote network from entering your router or your network, your local router. Or you can permit or deny access from your internal or VLANs, and then just either you block them from going outside or permit them to go outside of your network. Okay, so with the standard, we have a number ranging from 1 to 99, and then extended goes from 100 to 199 to, or 2000 to 200, 2699. Okay, so with ACL access control list, the standard one only block IP, block traffic based on source IP, and then extended blocks traffic based on various parameters. So you can literally block traffic. You can allow ping and block HTTP, or you can allow the web access and then block SSH. So you block traffic based on some parameters. It could be source IP, destination IP, protocol, port numbers. All right. So this is the topology we'll be working on today. So it's going to be like a quick lab illustration on how to implement ACL standard and extended. All right, let's get into it. So let's switch to the packet tracer where the real topology is. So we'll be working from here, guys. We have three routers: Dallas router, Houston router, and Austin router. So all these routers, guys, have ACL configured onto them. All right, and I just configure the IP route table on them. And let's see if there is any ACL configured as of now. Do show access list. As of now, we have access list 1 that I'm going to remove. No access list 1. It's gone. Show access list. We've got none. Configure terminal. All right. So let's get into it. So the goal here, let's define some objectives. We would like to only authorize VLAN 60 to ping or to reach Dallas router. So let's first start by testing the connectivity from all the routers. So from Austin router, we have a VLAN 61 into 168.60.0/24. Let's try to see if we can reach Dallas router on any VLAN. 192.168.10.26 reachable. Let's go to VLAN 70 and try to do the same. 192.168, let's try 20.26, VLAN 20. It's reachable. And let's move on to Houston and pick one of the PC from VLAN 50 and try to ping VLAN 30 in Dallas, reachable. So now we have confirmed that all these VLANs from the three routers can reach Dallas, or they can reach each other, okay? So now let's go back to the router in Dallas and define our first standard access control list. So we say access list 1 permits 192.168.60.0 wildcard bits 0.0.0.255, enter. Now we need to apply, so this rule, we have created rule number 1, access control list 1. with a rule that's permitting 192.168.60.0 to enter this router. But as of now, the rule is not in action yet. To actionize the rule, we need to apply it on the interface, the inbound interface or the outbound interface. So as we're looking to the router here, if we want to allow only VLAN 60 to ever reach network in Dallas, we need to place it here where the entrance is. So when traffic leaves VLAN 60 coming to Dallas, they have to come to serial 001. So let's go to the serial 001 in Dallas site interface, serial 0-01. We say IP access group. So here it's not access list. When we apply it on the interface, it's called access group. And when it's applied on line VTY to block SSH, we call it access class. Access group 1, let's say in. Now, after doing that, so as you guys can see, we created an access list to permit only 192.168.60.0 with a wildcard bit of 0.0.0.255. So there is what we call implicit deny. So once we permit one network like that, implicitly we have denied any other network. So let me show how that works. We go to VLAN 60. Let's try the same ping test again. We're pinging VLAN 10 in Dallas. So VLAN 60 is still authorized to go to Dallas. Let's go to VLAN 70. Previously, you guys saw that we were able to ping. Let's try that one more time. Now we are getting a destination host unreachable, and we're getting that message from 2221, which is the serial interface on Dallas side. So the 221 is the IP address on serial 001 of Dallas router. So we can see that our rule is being matched. If we do, for example, do show, let's go and back to privilege mode, show access list, enter, we can see we're getting some matches, 4 matches for this rule. So the ping sends like 4 packets and they've been all matched, right? And the ping was successful. So now there is an implicit deny which is blocking any other traffic. Let's say we want to modify this access control list 1 to also permit VLAN 70. We say access list. Let's make sure we repeat the same number. Access list 1 permits 192.168.70.0.0.0.255. Enter. As of now, 70 has also been whitelisted or allowed. Now, once we go here, as you guys can notice, it was showing destination host unreachable. Now we just added it to the route, to the rule, right? So if we ping again, we should be successfully able to connect, as you guys can see now. But VLAN 40 and 50 in Houston, we did not whitelist those networks. So as a result, if we try to ping again, we get the destination host unreachable. So this guy can connect because we need to apply this rule also on this interface. It's going to serial 000. So we have to go there, interface serial 000. We say IP access group 1 in. Then and only then these guys won't be able to reach it. One more time. Ping. And now we're getting destination host unreachable from 1.1.1.1. And so is VLAN 50. Destination host unreachable from 1.1.1.1. Okay? So now we can always go back to the same access control list and permit other network. Okay? All right. So now let's say we want to add everyone else on the access control list. We can either delete the access control list or say access control list 1 permits any. So remember guys, there is an implicit deny at the end of each rule. Implicit deny means there is an invisible deny. Let's say you're hosting a party and you invite 2 of your friends. So anyone whose name is not listed on the guest list, they are implicitly not invited or denied access to the party. And also remember where to place your ACL, the position, right? So once you're blocking some traffic, you need to find from which interface you have to place that access control list, and also specify the direction, whether it's incoming traffic or outgoing traffic. All right. Okay, so now we've seen what we call standard ACL. There's a lot of example we can do. We can either, let's say in VLAN 40, we can only whitelist a specific host. Instead of the whitelisting the whole network, we can say access list 1 permits host 192.168.40.26. Enter. Now 40.26, which is this guy, let's check his IP address. ipconfig. This is 40.26. I'm going to plug in a new machine. Okay, let's add one more PC so that we can get a second one. Okay, let's connect it. Pick any ports. Fast forward. And let's do an IP config renew, just to request an IP from DHCP server. One moment, it looks like it's loading. And after the loads, it loads, and then we should be able to do a ipconfig/renew so that the new PC, which we have added to the network, can request an IP address from DHCP server. And after that, we should be able to check its IP address and see if the rule we have defined is working as expected. So now it's complete loading. Let's go to the command prompts. We will do ipconfig/renew. Enter. Okay, it's thinking about it and requesting an IP. We got 192.168.40.27. So in the Dallas router for VLAN 40, although it is blocked, but we just had added another host to it. So do show, let's just go and show access list. So we have 3 rules. The first rule is permitting the whole network for VLAN 60. Second rule is permitting VLAN 70. Third rule is to permit one single host from VLAN 40, which is 192.168.40.26. Let's go there. This is 40.26. And let's try to see if we can reach any IP in VLAN in the Dallas router. Ping 192.168.20.26. It's reachable, right guys? Now let's go to the new PC that we just got. We'll ping the same 192.168.20.26, and we're getting a destination host unreachable just because we have only allowed a single host address, not the entire network, by a single computer or a single host. And this rule just got 4 matches. Nice. All right, so that should be it for the the standard access control list. Okay, so now let's do another example of how we can leverage extended access control list. Config T. Let's start by removing the standard, no access list. By the way, they can all work together, but I'm just trying to remove it so that it's clean. Now let's go to our Houston network. Open this PC. and we'll go to the web browser. We have some web server predefined already that I've already configured. We have one for kca.com and another one for fakebook.com. Okay, open the web browser. It's gonna take a few moments to load, and then we should be able to access it. As of now, I have removed the ACL, so there is no access control list. So we're going to test what we call extended access control list. One moment, guys. So with extended access control list, first of all, I would like to test if we can reach kca.com from the Houston PC on VLAN 50. If we can reach it, and then I'll go ahead and apply extended access control list so that that PC in Houston router, we can block the web and only permits ACMP, which is the protocol for ping. Okay. Once that is implemented, we can now try and see how extended works. Let's give it some time. It's still loading. So guys, while it's loading, let me just repeat it again. So standard access control list is only blocking the source traffic based on the network address. With extended access control list, it's blocking the traffic based on certain parameters. So you can allow ping and block SSH. You can allow ping and block HTTP. You can allow HTTP and block HTTPS, or you can also allow HTTPS and block HTTP. So when you take classes like AWS, you should be able to learn technology like application load balancer, which operates at layer 7. So with that, we have some tools called security group, which kind of like work like extended ACL, where you can literally authorize or permit some source IP to access the web and block them on SSH, or you can authorize anything, right? So you can just apply an extended list to allow any network, any protocol, any port number should also work. All right, so it has completed loading. Let's try to see if we can open it. Once we open it, we'll try to access the web browser, and then after that, we'll go back to the Dallas router and block, because in Dallas router, that's where we have our DNS server, where we have configured kca.com and fakebook.com. Let's start by trying to access fakebook.com. Actually, let's do by kca.com. kca.com. All right, let's click on go and see if we can reach it. All right, we can reach kca.com. Let's try fakebook. Go. Let's see. Fakebook.com is reachable. Let's go back to kca.com. It's also reachable. All right. So now let's leave this page. I'm going to go to Dallas router. Let's add one more PC in VLAN 70. And then this PC, we'll use it to test the ping connection. And then the other PC in Houston, we use it to test what's it called, the browser access. Okay, let me connect it to the white ports. Okay, all good. One moment. Okay. Come on. Okay, the bottom toolbar is gone. Let's request an IP address from this PC on VLAN 50. So the command will be ipconfig/renew as usual. We're almost there, guys. 19 minutes 56.7. So let's wait for this to finish loading and we can go ahead and test it. Okay. ipconfig /renew. Requesting from DHCP server. We should get 192.168.40 or 50.27 or 28. Okay, 27 is given, which is good. So we'll be using this PC in Houston to test the ping. Ping 192.168 10.26 reachable, and the other PC will be using it for our browser test. Okay, good. All right. Now let's go to Dallas and then try to create a list. Let me remove this OSPF. Do show run section OSPF. We have OSPF process number 1, okay? No router OSPF 1. This will just prevent us from no longer getting these messages. Good. All right. Access list 101 extended, start from 100 to 199. 101, let's deny TCP from network 192.168 50.0.0 50.0 and then a wildcard bit of 0.0.0.0.255. And next, what do we need to filter? The destination address. Let's say any. Next, we need to filter for the match packet by on a given port number. So let's say EQ 80. So this is deny. Enter. And then we can say access list and allow anything else. 101 permits IP any source, any destination. Enter. And then we need to apply it on the interface. Interface S000 IP access group 101 in. So interface 000, it's where we have defined the static route between Dallas and Houston. Here. So now let's go back to the second PC of VLAN 50. Let's try the ping. Our ping is still going on. And we have another PC where we were using for web access. Let's try to refresh it by clicking on go and see what happens. Let's go to fakebook.com. As you may have seen, fakebook.com is hanging. We're still on the KCA page, and eventually we should get request timeout. So the same VLAN, one PC is able to ping, continues to ping after applying that extended rule, and another one is blocking the browser. As you can see, it's request timeout. So on VLAN 50, we can ping. Ping is still allowed, right? But web access is blocked. So this is the power of extended access control list. Let's go back and try kca.com. KCA.com, we're also getting request timeout. Let's do a little recap on this. With extended list, let's check that out. Show access list. We have an extended access control list that's telling us that, first of all, rule number 10, we are allowing traffic from this network, only the www. So 80, which is the protocol for HTTP, so it's equivalence of www. We got 51 matches, which being denied, and then we are permitting any other IP. IP protocol, it could be ping, SSH, anything that uses IP from any source, any destination, and we have applied that list to serial 000 to block the traffic that's coming in. So now we're going to define one more rule to block traffic that's leaving Dallas network. As you guys may have seen, in Dallas network, we have VLAN 10, VLAN 20, and VLAN 30, okay? Config T. Now we're going to block traffic within the Dallas network. We're going to block VLAN 10 from not leaving Dallas, okay? So let's start by removing the access list 101. Now let's define another list that we can utilize to block traffic from not leaving the Dallas network. Okay, so we'll say access list (101) destination this source network permit. Let's say deny IP any. We're denying the IP protocol from 192.168.10.0.000.255 from not going anywhere. Enter. So access list 101 deny IP of network 192.168.10.0.0.255 to any network, any destination. We're blocking it. And then we can say access list 101, let's permit IP any. So we're going to apply it to the exits that are leaving the Dallas network. As of now, this list is not applied anywhere, so we can ping from within Dallas to the outside world. Ping 192.168.50.26 from Dallas PC, reachable. Let's go to VLAN 20 and do the same. Ping 192.168.60.27 reachable. We go to VLAN 30 and try to ping outside. Okay, 1 second, it's still loading. So as you guys may see, VLAN 10 is able to ping outside. VLAN 20, we just verified that it's able to ping outside of Dallas. And VLAN 30, we're about to test it. Now, I'm sure it's going to ping. Okay, let's go to command prompt, CMD. Can I say ping 192.168.40.26. Thinking about it, and let's wait. Request timeout, reachable. Okay, nice. All right, so now we have verified that all the LAN within Dallas can go outside. So let's define a list. We've already defined a list to block, to block only VLAN 10 from not going out. And we have permitted anyone else. But everyone is pinging as of now because we haven't applied it to any interface. So we go interface S000, we say IP access group, and that list was number 101. We say IP access group 101 out. 101 out. And we go to interface 0001 IP access group. Now the position, the direction is outbound, right? Out. Out. So now let's try to ping it. So we have defined the outgoing interfaces. So from Dallas to go out to external network, we use serial 001 or serial 000. Okay, now let's go back to Dallas PC. Try to go outside. Previously we were able to go to 50.26. Let's try the same. Now, this guy is getting destination host unreachable. So VLAN 20 is no longer able to go outside. Let's test for VLAN 10 is no longer able to go outside. So now let's test for VLAN 20. Trying to go to 60. Reachable, which is good. And 30 should also be able to go out. 30 is going out. As you guys can see, VLAN 10 is getting destination host unreachable. And the two other VLANs, VLAN 20 and 30, are being granted access to go out, okay? All right, so this is all I covered today. So remember, standard ACL, it's just used to block a specific source network address or specific source host address. And then extended access control list is used to basically block traffic based on some parameters. We can block traffic, we can block HTTP or web traffic and allow RCMP or traffic, or can allow SSH and block Telnet. We can allow FTP, and we can even block OSPF. We can block DHCP from serving and allow other traffic, right? So this is all about our access control list. Very, very useful for security. So just please keep following this page. We will be uploading more videos related to Cisco networking. Thank you for watching, guys. This is David again from KCA. And then remember, all the KCA students, in March 7, we have an event coming up where we all gather together, meet together, and have a hands-on lab. And also for anyone else watching from the internet, in April the 20th, we're starting a new session with Cisco CCNA, and the registration starts February 7 and will end in March 10. All right, thank you again for watching, and see you in the next videos.